Okay, so we have this question here. It says a bag contains 1 gold marble, 9 silver marbles, and 23 black marbles. Someone offers to play this game. You randomly select 1 marble from the bag. If it's gold, you win 4. If it's silver, you win 2. If it's black, you lose 1. Now, I know you haven't been doing this. You've been doing it your own way. But when I do these problems, I like to draw this chart here. So it's going to be 3 vertical lines. And then depending on the number of outcomes, you're going to have that many horizontal lines. So there's 3 outcomes here. So we have 3 horizontal lines. Okay, and then I'm going to label this. The first one's going to be outcome. Second one's going to be payout. Payout. Third one's going to be probability. And this last one's going to be multiply. This helps organize things a little bit better. So our outcomes, you could either pick a gold, silver, or black. So we'll just put gold, silver, or black. What's the payout if I pick a gold? I win 4. Silver, I win 2. Black, I lose 1, so that's -1. Now the probability of gold, there's 1 gold, and there are 33 marbles. 1 plus 9 plus 23, so there's 1 out of 33. There are 9 silvers, so this is 9 out of 33. And this would be 23 out of 33. Now I'm just going to take these payout probabilities columns and multiply them. So this becomes 4 out of 33. This becomes 18 out of 33. This becomes -23 out of 33. Okay. The very last step is to just take these 3 boxes and add them up. So I'm just going to do it in my calculator. You can just do it right the way it looks. So we have 4 divided by 33 plus 18 divided by 33 plus -23 divided by 33. And I get 0.030303, yada, yada, yada. So I get -0.03. Okay. All right. The next one you said was this one is a couple plans to have 3 children. What is the probability that they're all girls? So it's not exactly, but let's just assume the probability of a boy or girl is 1/2. What's the probability they have all girls? That's basically saying, like, if I flip a coin, what's the chance that it's going to be tails, tails, tails? Well, how many different ways can this be done? How many different ways can they have 3 children? So let's just say here's the first child, second child, third child. How many ways, it's a weird way of saying it, how many ways can they have the first child? They can have a boy or a girl. So there's 2 ways they can have the first child. How many ways can they have the second child? There's 2 ways for the second child, boy or girl. And the third child, 2 ways. So the number of total ways they can have 3 children is 2 times 2 times 2. 8 ways. So if someone you know has 3 kids, there's only 8 different ways that can be divided up between boys and girls. All right? So what's the chance they have all girls? Well, there's only one way they can have all girls, and that being all 3 of them are girls. So this is just going to be 1 divided by 8. Okay? Now this says they have at least 1 boy. All right? So this is an easier question, because this means you have to figure out the probability of having 1 boy, 2 boys, or 3 boys. That's a little bit more complicated of a problem. But I can find the complement of this. Probably they have at least 1 boy. Let's say I want to find the complement, so I'll say, what's the probability of having no boys? Right, at least 1, the opposite would be none. So if I figure out the probability of no boys, I can just subtract that from 1, and I'll get my answer. Okay? But it's kind of a convenient question because we already found that. The probability of no boys is the same thing as saying the probability of all girls. So if I want to find the chance of having at least 1 boy, it's just going to be 1 minus 1/8, which would give me 7. eighths. That's it.